Okay. Looking at 296, we're going to kick off this discussion on empirical formulas, how to determine formulas using stoichiometry. It says a chemist decomposes an unknown compound. So we've got a decomposition. I'm just going to write this on the board. If we generically speak of a decomposition as molecule ABC produces A's and B's and C's, right? What is a decomposition reaction? That's a decomposition reaction, generally speaking. Okay, a chemist decomposes an unknown. The products of this decomposition are 12 grams of carbon, 12.0 grams of carbon, and 4.04 grams of hydrogen. And leave it like that for now. What is the chemical formula of the unknown compound? Okay. If I take the hydrogen, we know it's typically going to be a homonuclear diatomic. We're going to see it in that form. Okay. That answer is correct. It is CH4. Let's go through a process now, just like with stoichiometry. You kind of delude yourself it's easy, and we always start with an easy example. So if you look at it, you see the answer, and then you don't figure out the process, you might be cutting yourself short, because in the future, they're not going to be that straightforward and simple. This is obviously a very simple one. Because we recognize certain things about this. We know that, for example, carbon has an atomic, as a molecule, has a molecular mass of 12.0 AMU, right? And we know that hydrogen has a 1.01 AMU atomic mass, right? An atomic mass, and an atomic mass of carbon over here. But thinking more generally, when we know that we do a decomposition reaction and our products are carbon and hydrogen, what must the original molecule be made up of? Welcome. What must the original molecule be made up of? Arsenic and rubidium? No, no. The original molecule was made up of whatever has been the product of decomposition. The original molecule is made up of carbons and hydrogens. Remember, we're not changing the elements. We're not performing alchemy here. We're just rearranging the blocks. And I still have the Duplos in my bag if anybody's curious, okay? So we're just rearranging the blocks. We know that we've got some combination over here. We've taken a single molecule and broken it down into two different products of reaction. So we know that our original molecule had to contain a certain number of carbon atoms, because carbon is one of the products, and it had to include a certain number of hydrogens, because hydrogens are the product of reaction as well. Okay? The question is then to go ahead and solve for what are the values of x and y? What are the values of x and y? Now, because we know over here the atomic mass, if we didn't, we would just look at our periodic table in front of our book and look at the mass and see, okay, hydrogen has a 1.01 beside it. That tells me 1.01 AMUs per atom. And over here, 12.0 AMUs per atom. Our masses of our products are not in AMUs, they're in grams. So if I know that one atom is 12 AMU, I also know that 1 mole, right, is 12 grams. So how many moles of carbon do I have? 1 mole. I know that we're producing 1 mole of carbon, right? And looking over here on the right, I also know that I'm producing hydrogen. How many moles of hydrogen molecules? Because we're going to still be in the form H2, right? It has a atomic mass of 1.01 AMUs per atom, but we're not getting atomic hydrogen, we're getting molecular hydrogen because it's a homonuclear diatomic. So every H2 molecule has a mass of 2.02 AMU per molecule, right? How many moles of molecule do I have then if each one is 2.02? 2 moles of the molecule. Right. Another way you could have thought of that is said, okay, wait a minute. How many moles of hydrogen atoms do I have? Well, each atom is 1.01 AMU, so each mole of atoms is 1.01 grams. I've been given 4.04 grams. I divide this 4.04 by 1.01, and I come up with 4. I have 4 moles of hydrogen atoms. Oh, wait a minute. Hydrogen doesn't go around as an atom. It goes around as a molecule. I've got 4 moles of atoms, which means I've got 2 moles of the diatomic molecule. Okay? 4 moles of the atom is the same as 2 moles of the molecule, because each molecule has 2. So the product of reaction is 1 mole of carbon and 2 moles of hydrogen. So I have a molecule. Now to put in X and Y, for every mole of carbon produced, I need to have 1 mole of carbon reacted, in this case decomposed, right? So what is my value of X? It's just 1. So it's an implied 1. I don't write anything. And hydrogen gas, over here, I have 2 moles of H2. How many hydrogen atoms do I need? 4. And I can't do that by putting a number in the middle of the molecule. All I can do is either add a coefficient out in the front. Excuse me. I can either add a coefficient in the front, or now I am actually going to work with subscripts. This is the first time up till now where we've been able to touch the subscripts, right? That's been the domain of God, not us up to this point. Right now, we're not making this molecule. We're discovering how God has already put it together. The way he's put it together is an X of 1 and a Y of 2 sets of 2 is 4. So it's a methane molecule, a CH4 molecule. The CH4 decomposes into 1 mole of CH4 decomposes into 1 mole of carbon and 2 moles of hydrogen gas. So again, we have a mass divided by a molar mass, mass divided by a molar mass to compute the moles to recreate the equation or the molecule.